Hello, this is Elif Öztürk. In this chapter 3, we are gonna explore quadrilaterals. Let's look at the question 1. The question 1 says that drag different vertices of a kite. Consider properties of sides, angles, and diagonals. Create a definition of a kite that encompasses all examples of kite. I drew it before on the sketch. Let's look at sketch. The definition of a kite is that there are two sets of adjacent sides next to each other. This one are their same length. It means congruent. And there is one set of congruent angles. There are opposites of each other and are between sides are different lengths. The intersection of the diagonals of a kite form 90 degrees. It means right angles. Also, we can say they are perpendicular. The longer diagonals of a kite bisects the shorter one, and as you see that the other kite I drew it before, these are bisects of the kite. Okay, let's look at the question 2. The question 2, reflect your own thinking process. What properties do you consider important or not important? Did you create definitions that did not work? How did you know if a definition worked or not? I think that there are two sets of adjacent sides next to each other that are same lengths, congruent. And there is one set of congruent angles is important because it makes a kite. I can create a definition which is there are two sets of adjacent sides that are same lengths, congruent, and there is one set of congruent angles. As you see that in my kite, diagonals are bisects. Is named a kite. The definition is wrong because, as I mentioned in the first question, just the longer diagonals of a kite bisects the shorter one, this one. I checked on the sketch the definition and I found different result of mine. As you see that just these angles are bisects and also the others one. I thought these F and H as angles can be the bisects, but they are not. Okay, go to the question 3. The question 3. Describe benefits and drawbacks of allowing students to interact with a constructed figure is a DGE to generate their own definitions versus a teacher providing a formal definition to students. I think when I give the students construct a kite for finding a definition is so helpful for students to create a definition that makes sense easily in their mind. They can find a proof by using DGE and then they generate their own definition even if it is wrong. They will be able to correct themselves. On the other hand, sometimes it's kind of hard to make a bisect and find an angle what you want exactly as did in my sketch. And as you see that FGE FG's degree is 44.05, but I couldn't make it. The other bisects 44.06, and I don't know how to make it, but I know the properties of kite, but it doesn't work on my sketch. This is incorrect. I could not make the same degree even there are two sets of adjacent sides next to each other. There are same lengths, congruent. It can make confuse the students sometimes. Okay, let's go to the question 4. When students are generating their own definitions, describe how a teacher can bring these different ideas together so the class is eventually working to form a single definition. The first time a teacher should give them just a shape of kite, then want from students find properties of a kite. Then the teacher can write all the font definitions on the board. Last, they can generalize the definition of a kite. I think it works in this way. Okay, question 5. The question 5, determine if the 5 definitions of a square just listed are all equivalent. Explain. The definition 1. A square is a quadrilateral with 4 concurrent sides and 4 right angles. As you see that the sum of the interior angles of any quadrilateral is 360. If all the sides are 90 degrees, right, which means also the lengths of the sides are the same, and it makes this quadrilateral a square. This is, and also there are different degrees of angles. Also the sum of them is 360, but all sides are not equivalent. Definition 2. A square is a parallelogram with 2 adjacent congruent sides and 1 right angle. Okay, look at these my shapes. I draw it before. Imagine extending the pairs of opposite sides. They could never intersect because they are parallel. Notice also that the opposite angles of parallelogram are congruent, as are the opposite sides. Angles of a parallelogram are congruent as are the opposite sides. Remember that congruent means the same size. The geometric symbol for congruent is also different. Also, as you see that the AD is parallel BC and DE is parallel AB sides. The relationships are lengths. Also, AD equals BD and DG equals AB. And especially if the degrees of A congruent of the degrees of B, A, B, the congruent of B, I could say the total sum of these angles must be 100 AD. But if these A and B angles are congruent, it means it makes them 90 degrees like the right angles. And also it makes it as parallelogram a square. Also, a square is a rectangular because it has 2 sets of parallel sides and 4 right angles. A square is also parallelogram because its opposite sides are parallel. These opposite sides are parallel, so a square can be classified in any of these 3 ways, with parallelogram being least specific description and square is the most descriptive. Okay, the definition 1, 2, and definition 3, where it is. Anyway, definition 3. I found it. Definition 3. A square is a 4-sided regular polygon. Go to the sketch or okay, 4 sides polygon. Can I find it? Just a second. Chapter 3 answer. let's find a polygon. Yes, as you see that this is a polygon, and four-sided polygons is a quadrilateral. Square is a quadrilateral with four equal sides and four right angles. That is why a square is four-sided regular polygon. As you see that these are polygon, but they are not. They have not the same sides. If they have the same sides, it makes it a square. The definition 3 is like that. Look at the definition 4. A square is a rectangular with four congruent sides. Okay, with four congruent sides. Look at this rectangular and the square. All squares are rectangular, but not all the rectangles are square. If the short sides and the long side is equivalent for the rectangular, it makes it a square. As you see that if long equals to short, it makes it a square. Okay, the last one is definition 5. A square is a rhombus with at least one right angle. Okay, go to the sketch again. Another quadrilateral is called a rhombus. All four sides of a rhombus are congruent. Its properties include each pair of opposite sides are parallel. Also, its right makes it a square. Yes. Question 6. Based on the stated criteria for mathematical definitions, which of the 5 definitions do you believe it's best? Explain. I think the first one is square is a quadrilateral with four congruent sides and four right angles. More general meaning and the best definition for me. Quadrilateral contains even rhombus, parallelogram, and rectangular. Here's my shape. Yes, you can find it on this. The quadrilaterals. As you see that quadrilaterals contains even rhombus, parallelogram, and rectangular. The first definition gives the basic properties of the definitions of a square. Question 7. Find to create a sixth definition of a square that's different from those that are listed. Explain why your definition is equivalent. The sixth definition of a square is all diagonals are equivalent, and the intersection of the diagonals of the square is form 90 degrees like right angles. This is my sixth definition. It makes it a square. Question 8. Consider the 5 definitions of a square listed earlier. If you wanted to select one of the 5 present to students, which would you select? Why? I think the first one is square is a quadrilateral with 4 congruent sides and 4 right angles, more general meaning, and the best definition for presenting to students. Quadrilaterals contains even rhombus, parallelogram, and rectangular. The first definition gives the basic properties of the definitions of the square. That's why I prefer. Question 9. Of the 5 definitions of a square, which do you think would be most difficult for students to understand? Explain. I think the definition of 3, which is a square is a 4-sided regular polygons, is kind of difficult to teach the students. 4-sided polygons is a quadrilateral. They sometimes confuse about the meaning the quadrilaterals and polygons. They cannot make a specific of a polygon as a square like a square is 4-sided regular polygon. Question 8, Question 10. Consider the following definition of a quadrilateral A quadrilateral is a four-sided polygon. What do students need to understand in order to make sense of this definition? Create three examples of three non-examples of quadrilaterals based on these definitions with or without or a DGE. Okay, go to the sketch again. The polygons ACBD has four-sided, but the angles of this polygon does not have a right angle. That's why it's not a square. The other one, polygon AEGHF has four sides. However, these polygon sides are not equivalent. That's why it's not a square. The other one, as you see that, the polygon EGHF has four sides. On the other hand, the side of IK is not parallel to side of IG. These are IG. It's not a parallel to sides of also KL. That's why it's not a square. Yes, that's it. Question 11. Select one of the two definitions and describe how you would construct a square using this definition. Create your construction in DGE. I used GeoGebra for definition 1 and 2. Definition 1. A square is a quadrilateral with four congruent sides and four right angles. It's four congruent sides and four right. As you see that all the sides are congruent, and 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yes, it has just three little sides, and also all the angles are right angle. Definition 2. A square is a parallelogram with two adjacent congruent sides and one right angle. Yes, the other one is also, as you see that, right and right. All the angles are right. That's why the square is a parallelogram and with two adjacent congruent sides, and one right is angle. Okay, question 12. A definition does not explicitly state every property of figure is defined. Explore the construction of your square to describe additional properties, diagonal symmetry, measures of angles. On the separate piece of paper, create a table like the one shown in table 3.1 and record your properties. Definition 5. If the intersection of the diagonals form 90 degrees right angle and all of them equivalent to each other, this means it's a square. The definition 6 can be, if we rotate 4 times a segment, it will be a square. That's why the pairs of opposite sides are symmetry. Question 13. Analyze two these definitions just presented. Which properties of a square are highlighted? Is one of the definitions easier to use constructing? In my opinion, definition 1 is a square is quadrilateral with 4 congruent sides and 4 right angles. It's easier to use for constructions because just we need for the same length of sides and connecting with two sides is right angle is easy to also it's easier to use for constructing. Question 15. Is a parallelogram a trapezoid using definition 1? What about definition 2? Explain. Definition 1 is a trapezoid is a quadrilateral with exactly one pair of parallel sides. The definition 2 is a trapezoid is a quadrilateral with at least one pair of parallel sides. Sometimes people define trapezoids to have at least one pair of opposite sides parallel, and sometimes say there is one and only one pair of opposite sides parallel. The parallelogram fits the at least one version of the definition because it has two pairs of opposite sides parallel. Therefore, it falls into the category of being both trapezoid and parallelogram. The parallelogram does not fit the one and only one version of definition. Definition 1 is the best for describe. Question 16. Which definition of a trapezoid was used in quads.gcp sketch? Explain how you determine your example. Okay, open the quads. Or it doesn't important. I have already opened in my sketch. The definition 1, a trapezoid is a quadrilateral with exactly one pair of parallel sides, was used in the quads.gcp sketch. As you see that in my sketch, there is just one pair in parallel sides. Just a pair in my AB is parallel DC. There is just on the other hand, AD is not parallel BC. Question 17. Which definition of trapezoid do you prefer? Why? I prefer the definition 1, which is trapezoid is a quadrilateral with exactly one pair of parallel sides because it's certain for the properties of the shape of trapezoid. Question 18. What are the benefits for teachers and or students for using the second definition of a trapezoid rather than the first? What are the drawbacks? The definition 2 is that trapezoid is a quadrilateral with at least one pair of parallel sides. If there is just one pair of parallel sides, it is a trapezoid. If there is no pair of parallel sides, it is a quadrilateral. I can say the benefits of definition 2 is that students is going to know it is not obligations to have at least one pair of parallel sides for being a trapezoid. In my opinion, the drawback is for definition 2 is confusing. If there is two pairs of parallel sides, it will be a parallelogram. But it's not a parallelogram, it's just a trapezoid. Question 22. Is there another way to create a hierarchical classification of quadrilaterals? Create a second method. Explain your decision. Let's go to the other shape. As you see that the quadrilateral is a mathematical name for the four sides polygon. Parallelogram, squares, rectangular, and trapezoids are all examples of quadrilaterals. The quadrilaterals earn their distinction based on their properties, including the number of pairs of parallel sides they have and their angles and side measurement. Question 23. Okay, go to the 23. The 23 says that use the diagram you create in question 14 of a hierarchical classification system for quadrilaterals for determine whether the following statements are sometimes true, always true, or never true. A. A rectangle is a parallelogram. It's always true. B. A square is a rectangular. Always true. A rectangular is a square, true. A cycle quadrilateral is a parallelogram. It's never true. E, a square is a trapezoid, never true. F, a rhombus is a parallelogram, always true. G, a square is a rhombus, it's always true. H, a parallelogram is a rhombus, it's true. Question 24. Which one hill level of thinking is needed for a student to make a list of properties of different quadrilaterals using a DGE sketch? Which one hill level of thinking is needed for students to classify the quadrilaterals? Yes, as you see that this is one hill level. I think level 2 is for classify the quadrilaterals. Students identify a figure based on properties. The properties are seen as independent of one another. Level 3 is for make a list of properties of different quadrilaterals. Students are able to analyze the interrelated properties of figures. Students also understand relationships between different figures. Question 25. How might students' uses of a DGE to explore quadrilaterals and their properties influence their geometric thinking? Using a DGE affects students explore quadrilaterals and their properties well, because they can find the length of sides, what is the situation of each side, find the angles, and find many properties of a quadrilateral, and they can clarify what the name of the shape. Question 26. Students often have difficulty determining whether statements, such as those in question 23, they are always true, sometimes true, or never true. Use the one hill levels of provide an explanation for why this may be a difficult task for students. Describe how a teacher could assist students in answering questions such as these. Look at this shape. As the question says that the students often have difficulty determining whether student statements such as those in question 23, always true, sometimes true, or never true, because the figure below shows that some of the shapes has common properties. The teacher can assist the students, show them the similarity and the differentity of shapes by using DGE. Question 27. Consider the topic Properties of Quadrilaterals. Create one task appropriate for students who is at each of the 5 different one hill levels. Okay, look at my level 0. Okay, can look at my answer to see levels. Okay. The level 0 says that recognition of a visual skills, children at the visualization level think about shapes in their terms of what they resemble. At this level, children are able to sort shapes into groups that look alike to them in some way. For example, a mountain can be a triangle. Level 1. Analyze, drawing, and verbal skills. Children at the analysis level think in terms of properties. This is a parallelogram. They can list all the properties of a figure but don't see any relationships between the properties and don't realize that some properties imply others. Level 2. Ordering or informal deductive. Verbal skills. Children at the informal deduction level not only think about properties but also are able to notice relationship between and within and between figures. At this level, children are able to formulate meaningful definitions. At this level, children are also able to make and follow informal deductive arguments. For example, all squares are rectangular, but not all rectangles are squares. Level 3. Deduction or formal deductive logical skills. Children at the formal deductive level think about relationships between properties of shapes and also understand relationships between axioms, definitions, theorems, corollaries, and postulates. They understand how to do formal proof and understand why it's needed. For successful completion, the typical high school geometry course requires geometric understanding at the formal deductive level. Okay, the last one is level 4. Rigor, applied skills. Children at the rigor level can think in terms of abstract mathematical systems. College mathematics majors and mathematicians are at this level. In 1990, two researchers, Clements and Batista, hypothesized that a level exists that's below visualization. They called it pre-recognitions. Children operating at this level wouldn't be able to distinguish a three-sided figure from a four-sided figure. Most elementary scholars are at the visualizations or analyze levels. Some middle school children at the informal deduction level. The 6 NAEP notes that most students 4th, 8th, and 11th grades appear to be performing at the visualizations level. It's desirable and to have a child at the informal deduction level or above by the time he or she finished middle school. Question 34. I skip some questions. Question 34 says that is the island vase if the island was of a particular shape, would you suggest using this method? Explain. The older brother suggests that they divide the length among the diagonal. Okay, first of all, let's look at the questions. The question is, consider the following scenario. Two brothers are part of an expeditions and they have discovered a new island. From the sky, they notice that the island is shaped like an irregular convex quadrilateral. They are not sure of the actual dimensions of the island, but they want to determine a way that they can fairly divide the island between the two of them. Problem similar. Okay. The older brother suggests that they divide the island along one diagonal. Then each can have one triangular part. He states that because this method creates two triangles and each will receive one of the two triangles. Is it fair? I think the older brother suggests that this one, but it's not fair. He states that but because this method creates two triangles and each will receive one of the triangle, if the island is a square, rectangular, trapezoid, or parallelogram, rhombus, then it works to divide the land along one diagonal. After dividing, there will be two triangles, which are the same area. In that time, it will be fair. But I don't suggest to using this because we don't know what's the shape of this quadrilateral. Question 35. Use a DGE to determine another method for dividing the land fairly between the two brothers. Be prepared to explain why your method works. There are multiple solutions to this problem. Some of them, the most common approaches, are shown here below and can also be found in the sketchpad. The solution 1, and I drew it before, as I said that. The solution 1 can be one way to divide the land evenly to connect the midpoints of each set of opposite sides, and G, F, E, and H are midpoints. If each brother takes two of the non-adjacent sections, the total area of their land is equal. In the solution 1, as you see that the area BGIF 35.58 centimeters square, and the other ones also, as you see, the length of the area of land. And if the area BGIF plus area EDHI equals 66.08 centimeter square, the area IGAH plus area FIEG equals 66.07 centimeter square. And as you see that that can be the solution 1. The other solution can be also suppose that ABC is a quadrilateral and points F, E, G, and H are midpoints. And also I is the intersection of point EG and FH. Construct BI, CI, AL, and DI. Now, if each brother takes one triangle partition from each of the colored sections below, one blue, one red, one yellow, and one green, and without taking adjacent pieces, they will have equivalent amounts of land. This method works because the area BIF and the area FIG are equal, since they have equivalent bases, because F is the midpoint and they have the same height. Let's represent each of these two equal areas with A1. Similarly, area CIE and area EID represented by A2, area DAIH and area HIA dominated by A3, and area AIG and area BIG represented by A4, each have equal areas. Thus, S1 equals A1 plus A2, S2 equals A1 plus A4, S3 equals A3 plus A4, and S4 equals A2 plus A3. If we combine these, we get S plus S3 equals S2 plus S4, like this, and 66.0507 centimeter square equals the other area, the total area of them. Okay, this is also the solution 2. What about the solution 3? The solution 3. A third solution involves finding the midpoints of each of sides of the quadrilateral and forming the midpoints quadrilateral with segments. There will be two areas that are equal. The area of midpoints quadrilateral is equal to sum of the four triangle regions surrounding it. These are. The solution 4 can be another solution is to create one diagonals BD in the figure and mark the midpoints of the diagonal point 1 in the figure 1. Since point I is the midpoint of diagonal, the measurement of BI and the measurement of DI are the same. For these reasons, in triangle ABD and the areas of triangle of AID A1 and the triangle AIB A2 are equal since they also have congruent heights. As you see that I1 and I3. Similarly, the area of triangles BCI A3 and triangle CID A4 are equal. Thus we have A1 equals A2 and A3 equals A4. In this context, there are two possibilities in order to share the length equally. First, one of the brothers could have S1 and S4, and the other could have S2 and S3. Or one might have S1 and S3, while the other might have S2 and S4. Question 36. Suppose the brothers want to make sure they each have lengths that's on the water. Devise a method that will satisfy each brother. Be prepared to explain your solution. We cannot say the relationships it's always true, that is, if you create the diagonals of the quadrilateral, measure the areas of each of the triangle regions created, and then multiply the area measurements of two non-adjacent triangles. But products are equals. As you see that below, each area has different. 38. Each area has different. Yes. 38. Describe the mathematical goals this text addresses. I think this text addresses some goals, which is draw polygons in coordinate plane given coordinates for the vertices. Use coordinates to find the length of side joining points with the same first coordinate or the same second coordinate. Apply these techniques in the context of solving real-world and mathematical problems. Secondly, solve problems involving scale drawing of geometric figures, including computing actual lengths and areas, form a scalene drawing, and reproducing a scale drawing at a different scale. Last, use facts about supplementary, complementary, vertical, and adjacent angles in a multi-step problem to write and solve the simple equations for an unknown angle in a figure. Question 39. If a teacher posed this problem to students in a classroom, it is likely that students would develop more than one correct solution. Anticipate that different solutions students might develop. Describe how each of these solutions is related to mathematical goals. Finding more than one correct solution is a good way to explore geometry for students. As you see that up, there are 4 solutions to divine a length. Their solutions are related to mathematical goals that they are able to make, such as addition, multiplication, and division. Question 40. For each of the solutions you anticipated, which would you have students share with the class? If you would share more than one solution, in what order would you have students represent their solutions? I would prefer to have students share solution 3. It seems easier than the others. I don't want to make them confused a lot. On the other hand, if they find more than one solution, I will be appreciated to see this answer on the board and we can discuss on it with all class. Question 41. What do you notice about the triangle EFG? Create at least two different interesting conjectures based on the diagram. Yes, this is a diagram. I can say, as you see that I found these numbers, but don't see these numbers, and I found two conjectures. I think it seems the point. Where's my other? Anyway, I couldn't find it. I think it seems the point A, E, and the point F, and the point G is a midpoint, are a midpoint. The other conjectures can be that the triangle of EFG is a isosceles. Question 42. Select one of two conjectures and determine whether it's never true, sometimes true, or always true. For this quadrilateral, my first and second conjectures are always true. The figure shows that why it's true. Yes, the G is midpoint because the length of the G equals G C, and also CE equals AE, which is 9.72 centimeters, and also DF equals FB, which is 11.23 centimeters. My conjectures is always true. Question 44. Describe some ways that teachers can assist students in using technology to gather data that can assist them in constructing formal mathematical arguments. There are some ways that teachers can assist students in using the technology such as GeoGebra or Sketch. To gather data can assist them for finding the answers to some questions, or they can prove the theorems with this. As you see that my conjectures is always true because I prove it on Sketch. Question 45. Create a new problem that extends the given situations and provide a sample solution. Recall that problem posting strategies were presented in chapter 2. Yes, as we found a solution before, we did like A can be the side A, side B, and side C can be a triangle or not. And let's made it 3 and made it 4 and made it 5. Yes, these sides ABC can be a triangle or not. I think it can be a triangle because all the vertices cannot connect in one point. Yes, it can be a triangle. Question 46. Consider the quadrilateral problem presented at the beginning of section 5. Describe the dragging strategies that you used and the purpose for using that particular type of dragging. First of all, wandering dragging, moving a point in the plane randomly while observing relationships and behavior. Second, quiet dragging points to achieve a particular shape. For example, dragging vertices of a triangle, like this, and I drag the points. Last dragging test is dragging a point and objects to see if it maintains in an extended properties. For example, construction a square and dragging a vertex determine whether it's still a square. And that's why the dragging is important. Question 47. Were certain dragging strategies more or less useful in solving the problem? Explain. Yes, dragging strategies is useful to solve the problem. As you see that we need certain drag points for being useful for it, such as midpoint, perpendicular, or parallel. Question 15. What type of quadrilateral is EFGH? How did you arrive at your conclusion? This is my I think ABCD is a parallelogram and EFG and IH are the centroids of triangles. ABC, BCD, CDA, and DAI respectively. If EFG and IH are the centroids of a triangle, ABC, BCD, GDA, and DAB representatively, in that situation, AFGH is a square because the angles of GH, GFE, and F must be the right angle. That's why it is a square. Okay, look at the last question. Question 53. Create 4 additional tasks that you could post to students that are extensions or modifications of this problem. Task can be, look at my solution. Where is my solution? The task can be what kind of a triangle EFG? The task 2, prove that half the points of EFG and IH are centroid. Task 3, show that is there any other parallel sides. The last one can be show that which angles are the same. These are my tasks. Okay. Chapter 3 has finished. Thank you for listening.